Thank you all for being here. So the title of my talk is a little bit a long one. So it's everything you always wanted to know about fingerprinting browser extensions, but were afraid to ask. So hopefully you learn, and you can also not be afraid to ask afterwards in the Slack channel. So in short, I'm an associate professor at Stony Brook University in Long Island, New York. I work in all types of web security and network security and privacy. You can see there a few of the areas that I work in online tracking, which is the focus of today's talk. DNS security, web application fingerprinting, mobile browser security. So how are mobile browsers different than desktop browsers in terms of the security? Attack surface reduction. Can we take large web applications and shrink them down to the parts that we want to keep and get rid of the rest and the vulnerabilities in that rest of the code? How can we use honeypots and deception technologies for defenses in web applications? And finally, anti-bot technologies. So as I mentioned, the talk will be focused on online tracking, but please feel free to look me up and see all the other work that we've done in all these other spaces. So I'll start by just mentioning something that should be obvious to anyone who's a web user, that browser extensions are very, very popular, right? So browser extensions allow us to customize our browsers in a way that we want to do it, and it's not supported out of the box by browser vendor. And so probably the vast majority of the people attending this talk will have at least an ad blocker installed, right? And then probably a good chunk are using some form of online password manager, right? So such as LastPass. And then there is really, the sky's the limit in terms of extensions. So you have extensions that check the text that you type and make sure that your syntax is nice and clean, right? They have extensions that are searching for coupons when you're trying to purchase something so you get a better price, right? You have extensions that if you're a Pinterest user, you can save things in your Pinterest, right? And you can even interface with antivirus software that has trouble otherwise looking into your browser because of the end-to-end encryption these days. So browser extensions are very popular, and many, many users are using them, particularly power users. From a privacy perspective, they're also considered to be somewhat private, right? So if you're not familiar with browser fingerprinting, it's this idea that you can extract information from a user's browser, combine that information into a fingerprint, and that fingerprint turns out to be quite unique. So if you come to my website and I use JavaScript to, for example, read your screen resolution, extract your list of fonts that are installed on your machine, draw a complex 3D object in a canvas, and then read it back as bytes. It turns out that all of these, right, have effectively characteristics that are very dependent on your hardware stack, on your software stack, on your choices as a user. So this fingerprinting idea is well known, right? And so plugins, right, such as Java and Flash and so on, you could actually read this when you were doing this fingerprinting and incorporate them into your fingerprint. And a few years back, plugins were quite a big source of uniqueness, right? So they were considered a powerful fingerprinting vector. However, as you may already know, plugins are going or have gone the way of the dodo. So we don't really like plugins anymore. We think they're buggy, right? There's like third-party code running natively into your browser with high privileges. So Flash is deprecated, Java kind of in your browser, right? So most users these days don't really have plugins anymore, but they do have extensions, right? And so just to make it clear, extensions are built using JavaScript, CSS, and HTML, right? And that's it. You just build an extension. You have access to privileged APIs so that you can access cookies across all websites. You can access tabs. You can do all sorts of things, but you're not running code anymore, native code, in the way that plugins used to, right? So if you compare plugins to extensions, extensions are not, there is no way for a page to list the browser extensions that a user has installed. And the reason for this is that extensions, for the most part, are not meant to be there to help the page, right? So a page in the past would check if you support Flash in order to show you a Flash app. But when you have an ad blocker, right, obviously the page kind of doesn't want you to be using an ad blocker, right? But these are installed by users to augment their experience and to better their experience of browsing. They're not, for the most part again, they're not meant to be somehow collaborating with a website to better your experience. So the short story of this is that there is no API that a web page can use that says, give me your list of browser extensions. That doesn't exist, okay? So that would lead us to the question, are these extensions undetectable? So is it not possible really for a web page to discover what extensions you have installed? And if you've been using the web for more than a day, you most likely know that no, that doesn't seem to be the case, right? So there's a lot of websites that are actually able to detect that you're using an ad blocker, for example, right? And then they ask you to either pay for a subscription or turn it off or do something else, right? And so we know that clearly it's possible. But the question is, how is it possible, right? If there is no API that a website can use to inquire into your browser, how is it that a website knows that you're actually using an ad blocker, right? So that's part of what we will cover today. The next question is, okay, so what are the implications of a website knowing that you have extensions installed, right? So if you have an ad blocker installed, they can force you to disable it or pay them, right? But other than that, what are the implications of a website knowing what it is that you're running, right? The first one is sort of the obvious one, is that if I know what extensions you have installed, I can actually tailor my exploits. So maybe I know I have a vulnerability for a given extension. I know that you're running that extension, I being the malicious website. So I can now launch that exploit against the extension that you know have installed, right? So that's problem number one. Problem number two is that it turns out that because users choose to install extensions, your list of extensions reveals something about you, right? And about me. So for instance, if you look there at the bottom of the screen, if you have an extension that does like GPG in your emails, that means that you are technically savvy. And a website, if it's able to detect the presence of that extension, can actually already put a label on you about what it is that you know and you don't know, right? If you have some sort of coupon finding extension, now as a website, I know that you're price sensitive, right? I can place you in a certain socioeconomic category, right? If you have a favorite politician or a hated politician, chances are that someone has built an extension that whenever they find their name on the internet, they will hide the article or they replace it with some sort of swear word, such as the two extensions there on the bottom. So again, if I'm able to discover that you have such an extension installed, I can immediately peg you and peg your political leanings, right? And the same goes for religious leanings and for all sorts of other things that I can infer about because of your choice to install a given extension or not, right? So that's problem number two. And the third problem, which is also in the privacy space, has to do now with actually using this to de-anonymize you, right? So if you see there on the right, we have a bunch of users. And on the left, we have a bunch of extensions. And the whole idea now is that if I, as a user, have chosen a unique set of extensions to install, and the website can figure out that I have this extension installed, these effectively become a fingerprint of me, right? So if no other user, for example, if I'm user one and I have installed Ghostery, AdBlock Plus, and Smart Video, let's say, and there's no other user that has installed this specific combination of extensions, now I'm again unique. So I can leave this website, I can delete my cookies, right? I can do all the right things, let's say, from a privacy perspective. But then when I come back, the same three extensions are installed, the same three extensions are detected, and now the website can detect that it's actually still the user from yesterday, but now with deleted cookies, right? So, and even if it's not unique, right, now we're actually placing users into so-called anonymity sets. So maybe there's only 100 users that have your specific combination of extensions installed. And now I can use other fingerprinting vectors to uniquely identify you within the group of 100, as opposed to trying to identify you within the group of billions of Chrome users or billions of Firefox users. All right. So these are our issues from a privacy and a security perspective. So now let's discuss how is it that an extension can be fingerprinted or can be detected rather, even though there are no official APIs for a website to use. And we will look at two types of attacks or two types of techniques. The first one is related to web accessible resources, and the second one is related to the artifacts of an extension running in a page. So let's focus first on the web accessible resources. So unless you have tried to code a browser extension, you may not know that you have a number of files. Like I mentioned earlier, your extension is comprised out of CSS, HTML, and JavaScript, but these files are part of your extension. So they are not meant to be accessible from outside your extension, right? actually originally in the first days of extension frameworks, this could be done, and this led to all sorts of security problems. So by default, all the files in your packaged extension are only accessible from within the extension, right? However, developers or browser extensions at times need to be able to refer to these packaged objects from outside their extension, right? And you can make, you can consider various options for that. If I, for example, if you just donated my extension, if you just installed my extension and I want to ask you for a donation, I can open up a website, and then I can actually reference files from within the packaged extension. But if I'm referencing these files outside of the extension, somehow I need to be able to access these files. So we have this special tag for extension called Web Accessible Resources. You can see it highlighted there on the slide. And there, a developer of a browser extension lists all the extensions that they want to be available outside of their browser extension. So websites effectively can reference these these files that are part of their extension, right? And these can be JavaScript libraries, right? These can be images, like I mentioned earlier. So this is what the mechanism is supposed to do. It's supposed to allow a developer of a browser extension the ability to reference objects of that extension outside of the privileged extension space, right? So that's the intention. And you can see here how that would work out. If I'm building a page, right, I can reference, for example, an image. I can say Chrome extension instead of, let's say, HTTPS. I have my package ID, and then I'm referencing the specific file that I'm trying to include into that page, right? And the same thing for a script underneath. So that's the intention. The problem is that browsers do not differentiate between the links that somehow your extension has created and is injecting in public pages, referencing its own files, versus links that are just part of the page itself. So you now visit attacker.com or tracker.com, and now tracker.com can actually try to be referencing files from popular extensions, right? And so you can see here the problem that the page can just try to load a given WAR. If I want to know if you have an ad blocker installed, I can just try to load web accessible resources of popular ad blockers. And if the resource loads, so if I actually do find, an image from a popular ad blocker, then as a page, I can straightforwardly conclude that you as a user have actually installed that ad blocker, right? And now I can show you that banner that says your ad blocker is installed, you need to disable it or pay me money, right? And so this actually leads to a very straightforward and somewhat easy, I would say, attack, right? So you can see there the steps of this attack. So we can first collect as many extensions as possible from an extension store. So we can go out and crawl and collect a few hundreds, thousands of extensions, right? And we can then statically analyze them and look in their manifest files, like I showed you earlier, look for those that use at least one web accessible resource. And just isolate that. And then we just write a script that pretty much just loops through a giant array, trying to load a web accessible resource from each of these extensions on a public page. And then I have an event handler. And if it's an on error, I know that this object was not present, therefore the extension is not installed. If there's no on error firing, right, then I know that actually this file was present. Therefore, you have that extension installed, right? And there's been a number of academic studies here that I'm referencing at the bottom, where you can see that people have actually found, like, for example, the first one in 2017, Shostan et al., they found that half of the extensions that they evaluated actually had web accessible resources and they were therefore fingerprintable. And then once people have started looking at larger and larger sets, this number drops, but it still is a quarter of the extensions. So it's really a fish in a barrel kind of situation, right? It's a very simple attack that anyone could just sit down and do, right? So that's web accessible resources as an attack that can be used to unmask browser extensions, right? A second one is related to the extension side effects. If you think about this, the reason why you're installing an extension is because you want it to offer you something, right? So for example, you want a tab manager that your browser doesn't have present. You want a password manager that will nicely autocomplete your passwords and will sync them from a cloud that you prefer, right? You have reminders that will just add things to web pages. You have proofreaders, right? Like the Grammarly extension that will look at your text. So you really expect the extension to do something, right? And typically in this category, you expect it to add functionality that you like, right? Other extensions remove things that you don't like, right? So for example, obviously, if you're running an ad blocker, you want it to remove things from the pages that you go to, or you want it to be, to remove bloat in general. You want them to be more readable, right? So you sort of align the text differently. And finally, you may just want changes, right? You may want to just do simplify things. You may want to change background colors for whatever reason, right? So that's why people install extensions, because they expect these extensions to offer them something, and that something is typically manifested by changes in the page itself, right? So I have here an example. So you can see here a trailer of the Hackers movie, right? And this is just loading YouTube with no extensions present. And here on the next slide, you will see that we have the same video, roughly at the same timestamp, with an extension called Magic Actions for YouTube, which has more than 1 million users installed, right? And I have circled the differences. So if you look here, if you compare the before and the after, right, we have that light switch on the top left, which actually allows you to sort of, go dark and just make the page black. So I guess it's a nicer viewing experience, right? And you have an extra menu down here that allows you to do things like find subtitles, potentially download movies, all sorts of things that users may want, right? So this extension does exactly what the user wanted to do, right? It has added functionality, has augmented the UI of YouTube. The question is, however, are these changes now discoverable by the page itself, right? And the answer is yes, and we will see this together. Another example is LastPass, right? LastPass will add special buttons in the forms of websites that you go to. And again, these extra buttons are part of the page's DOM, right? So if a website just knew where to look, it would say, oh, look, there is this button in that form, and I know that I didn't place it there. Therefore, the current user has LastPass installed, right? And so it turns out that extensions have visible side effects, right? Because that's exactly what you install them, because they offer you something, right? And so what we did in 2017 is we sat down and we built a system that will automatically compare a page with and without an extension for a very large number of extensions. And it will tell you whether an extension makes changes to a page that could be used to fingerprint, right? And so I won't go into too much detail in this talk, but effectively, you can see here that we are loading pages into Chrome. We are analyzing the DOMs. We have honey pages that allow extensions to manifest themselves. So there will be pages with images and pages with phone numbers and pages with links, so that different extensions will discover them and sort of do things to them, because again, that's why you install an extension. And then we have an automatic module that just compares the before and the after DOM, and it finds what are the unique changes that we can attribute back to the current extension that we're analyzing, right? And there is a paper that you can find online with all the technical details with that same title. So the results for that experiment was that for the top 10,000 extensions, we found that 10% of them roughly introduced detectable changes on any arbitrary URL, right? So if you would go to any website on the internet, that website had the power to fingerprint roughly 10% of extensions. However, if you were actually looking at popular sites such as twitter.com and Gmail and so on, these sites could actually unmask 16% of extensions. And the reason for this is because these websites are very popular, and you have a lot of developers who are making browser extensions specifically for these websites. So these are extensions that are only revealing themselves on gmail.com, on twitter.com, and therefore these sites now have the ability to fingerprint extra extensions, right? And you can see there on the graph on the bottom that we have actually a positive relationship between rank and fingerprintability. So the more popular an extension is, the more fingerprintable it is. And as you go down in popularity, you go down in fingerprintability. And the reason for this has to do with offered functionality, right? So the more functionality you're offered, the more popular you're offering, the more popular your extension will be, and the more functionality you're offering, the more chances that the extension will be fingerprintable, right? So, and what we discovered is that from all of these extensions, 86% actually were making at least one change that was unique to them, right? So you didn't have like two extensions making the exact same change. For 86% of the extensions, they were making a unique change, which means that if you detect that change, you can attribute it back to a specific extension, right? And you don't have to sort of try to guess which of the 10 extensions that do this exact same thing the user has installed. And we also checked the same extensions after 4 months, and we saw that you have roughly the same percentage of extensions in the store that remain fingerprintable 4 months later after many updates. So the fingerprintability of an extension is a stable property of that extension and won't go away unless the developer does something to that extension, right? And you can see their statistics at the bottom in terms of what the extensions did, such as 78% removing DOM nodes and so on, all right? So let me now contrast the two types of fingerprinting that we talked about. On the left, we have WAR fingerprinting, web accessible resource fingerprinting, and on the right, we have behavioral fingerprinting. right? So on the left, we see that, okay, for wars, it's easy to extract signatures. You can do it statically. It's easy to perform in the user's browser. There's no user interaction necessary. You just cycle through a long list of words. But the developers could just straightforwardly stop this, right? They can start referencing images and CSS from their websites or from CDNs and just stop with this altogether, right? On the right, we have behavioral fingerprinting. That's easy to perform in the user's browser. And it's actually quite more difficult to get rid of it because you really want these extra UI buttons and you want the ad blocker to be removing ads. So how is it that you can stop these changes that are the same changes that make that extension fingerprintable, right? On the negative side, it's more difficult to extract signatures. Now you need a system, right, that will exercise the extension, will reveal what it does, and you may even need user interaction that we haven't accounted for. So what we did this year is we introduced the third way, which we call here the middle way, which at least in our minds, this combines the best of both worlds, in best for the tracker, right? So we have easy extraction of fingerprints. We don't need user interaction, and it's difficult for developers to make their extensions non-fingerprintable. And our tool, our technique is quite deceptive. It's obvious in hindsight. It's CSS-based extension fingerprinting. And so again, if you're a developer, you love CSS, or you don't, but you still have to use them. And extension developers also need CSS, right? When they're creating their own buttons and their own menus and their own forms, they also need CSS to make them look the way that they want to look, right? So actually what's happening is that extensions come packaged with their own cascading style sheets, which are then injected in a page, right? So that when the extension adds a button or does other things, that button and these other things will be styled according to that CSS. And you may see where this is going now. So here we have an example extension called Dr. Web Link Checker. And the whole point of this is that you're visiting websites, and if this extension discovers a link on a website that is malicious, it will add this little flag there, this little shield that tells you that, okay, that something bad is going on, right? And you can see here that effectively the extension, when it discovers a malicious link, it will add this simple div element, right? And if you look at the CSS, effectively that's how that element is styled, right? And so we have the injected element, and now we have the injected style for that element, okay? Now let's talk again about the problem. Again, no differentiation between things that the extension did and things that the page did, right? So what can happen is that the page itself can have a div with the right class. And if it happens that the CSS of that extension is present, that div will inherit all the styles from that CSS. And so you can see here, we have this empty div. If you don't have that specific extension installed, if you do have that specific extension installed, suddenly we have that nice style div with the shield, okay? So again, now we have a differentiating or a diverging behavior, and we can use that as a building block for an attack, right? So pretty much you can see here on the left, we can focus on the extensions that inject CSS to pages. And we have found experimentally that more than 98% of CSS is injected statically. So you can actually detect it again at the manifest file. We can identify what are the CSS rules. Then the tracker can build decoy elements, empty elements that just have the right class names, the right tag names, the right class names, the right IDs, and then just sprinkle them into a page that the user will visit. And so once the user visits that page and his extensions add to the DOM all the CSS rules, now these elements will actually start inheriting styles from this injected CSS. And now the tracker, the page, can actually use quite a large number of methods to find out that the size of that div has changed, right? This used to be a blank, empty div, and now suddenly it's 100 pixels wide. Why? Because it inherited some CSS and something changed within it, right? So we can actually use this to, again, find out that a browser extension is present, even if nothing has been injected from the page, no buttons, nothing has been removed, just the CSS is there, right? But now we're actually abusing the CSS to uncover the presence of a given extension. And I can tell you quickly about our results. So we evaluated this attack on 116,000 extensions. 6,000 of these inject style sheets on all websites that you visit. Half of them have at least one CSS trigger that's unique to them. So again, if you get the specific element styled, it can only be one extension that has styled that element, all right? And you can see here on the top right, we have this Venn diagram where we compare different kinds of extension fingerprinting. So This is the web accessible resource, post-message fingerprinting that I didn't talk about today due to lack of time, DOM, so the side effects on a page, and CSS. And what's important to note is this number here, right? So we have 1,074 extensions that we can uncover using this CSS fingerprinting that we couldn't do before, right? So these were effectively invisible extensions by all the prior methods, but now our tool and our method has actually been able to figure them out. And on the bottom, you can see a performance graph of the number of extensions on the x-axis and the time that it takes to detect them on the y-axis. And so you can see here that even if you have a user who's a little bit on the crazy side and has like 20 extensions installed, we're talking about 15 milliseconds that it takes for the page to just run through all of your DOM elements, find out using these methods that they have been styled, and infer the presence of a browser extension. Right? I have a video that I think we do have some time, so let me try to do that. I was thinking of skipping it, so let me quickly share that video. And yeah, I've sped it up a little bit. You can see we have a page that pretty much shows you that we are currently detecting 20 browser extensions. And again, we're just abusing this CSS fingerprinting. No APIs there for us to use. And now what we're doing here is these are the 20 installed extensions. We will go in and we'll disable 3 extensions just to prove to you that this is all working well. So we're disabling 3 extensions, and we go back and we can refresh. And you can see immediately that we've dropped down to 17. So we were quite quickly able to discover that an extension is no longer present because the decoy elements that we're injecting are no longer inheriting any style sheets, right? So that's the attack, really. So let me go back to our slides. All right. So let's talk about defenses, and then I'll wrap it up. The most realistic defenses in terms of adoption are access control-based defenses. So you may have noticed in the last couple of years, probably 2 at most, that you actually have the ability to tell your browser that the extension should not be available kind of by default everywhere. You should first interact with it in order to make it available, right? It's still something that's opt-in. It's still something that you have to do. It's not there by default, but it is the right step in the right direction, right? And the example that I like to give is that, yes, you probably want your ad blocker to be enabled in general when you're browsing the web, but do you want it to be there on your banking website when you're logged in? Do you want to have a code base of hundreds of thousands of lines of JavaScript that someone else has provided? Do you want it to have access to your logged in page in your banking site? I think the answer is most likely no. So we need better access control and some way of syncing site preferences with extension developer preferences, with the user somehow being the arbiter. And it's very difficult. All the user study parts are missing for sort of deciding that this is going to work. But I think it's the right way forward, right? And then we have deception-based defenses that are more academic at the moment. But pretty much what we can do is we can just fake the presence of extensions by just having decoy CSS and decoy elements, so that the page thinks that you have one set of extensions installed, but you actually have a different set of extensions installed, right? So again, I'm not saying that this is ready for prime time, but it is a direction that at least academics are investigating. And with that, I want to conclude. So user customization has driven the web a lot, right? And so the ability for users to really customize websites and customize their browsers. But the effects of this customization, unfortunately, can be used against users through browser fingerprinting. Access control, like I mentioned, is the right way forward. And on the right there of that slide, I have 3 papers that have come out of my lab on fingerprinting browser extensions over the years that I would encourage you to look into if you're interested. And I'm happy to take questions in the right Slack channel. Thank you.